So Optimism implemented EAS into the OP stack. So every chain that deploys with the OP stack automatically has EAS built into it.
It's nice to get back to recording these episodes together with Austin. And today we have Steve from Ethereum Attestation Service, who's going to be talking about what even is Ethereum Attestation Service. And I think we're going to be picking his brain a lot. So I directly want to dive in. It would be great if you can explain what attestation is, and maybe we can start there and kind of move forward.
Sure. So simply an attestation is someone saying something about anything. So, me saying that I met you in real life can be an attestation. Someone posting a tweet can be an attestation. Someone giving you a credential is an attestation. It's in regards to EAS, an attestation is just a digital signature signed with your Ethereum wallet on a structured piece of data about something.
When I first came into this space, I had to learn arbitrage and attestation. I didn't know what either of those were. Plus, I had to learn like a bunch of economics and things that I didn't game theory, things that I didn't plan on learning as a computer nerd. But one term that comes up a lot is credible commitment. Credible commitments on chain, like when you put them on chain, everyone can see them. They're cryptographically backed. Attestations and credible commitments, similar things, one inside the other. What's the verbiage words there?
So I think attestation for this case makes more sense because an attestation doesn't necessarily have to be a commitment, right? Like word wise, like commitment might not make sense. You might have an attestation from a machine that's attesting to some supply chain movement. It's essentially an attestation covers it pretty fully. And actually, we really wanted to not have to use that word because it's not a word that people really use. But every time we try to find a new word, it just nothing kind of gave it was as descriptive as attestation.
And kind of at the heart, we have this like ECDSA key pair that can sign a thing, and you can prove using math that this account for sure signed this thing. And that's, I think, kind of technically the heart of making an attestation work, is that people need to be able to trust the information was signed by the person, and we can use math basically to prove it. Is that right?
Right. And you know, now that so many people have Ethereum wallets, it made sense to build this in this way. Because you have already technologies built around like verifiable credentials and signing with kind of various keys. But all the projects that kind of do this, they build these like siloed ecosystems, and just creates more fragmentation when it comes to like trying to build identity protocols or things like that. And so we realized that like it makes sense that today so many people have wallets. Why not build like the verifiable credential for EVM, right? That's lightweight, uh, does what a verifiable credential does, but like specifically built for efficiency for on chain and also off chain. EAS also lets you make off chain attestations, which is pretty cool. But specifically for Ethereum EVM based attestations, uh, that's what EAS is for.
So one thing which helped me understand more is especially like that it can be used for other use cases like reputation. So I'm like, we mentioned digital identity, but what are like the other use cases you can use EAS or an attestation service for?
Well, I mean, an attestation can be a vote. It can be used for supply chain. It can be used for verifying that some real world asset exists. It can be used for credentials. Uh, I like to tell this kind of story, like why we kind of built it in the first place. Um, I was really interested in decentralized identity. It's super important thing to solve, but identity is like highly complex. And EAS isn't, like you said, it's really not meant for just identity, but it was a really important problem that that we wanted to solve. And the thing about identity, it's like super complex, right? In the sense that it's both relative, right? In the sense that you might trust me as a good developer, but someone else might not. And it's also contextual in the sense that you might trust me as a good developer, but maybe not as a good dancer or something like that, right? And so I started like to think like look at all the platforms out there that were kind of messing with this, and they all like kind of presuppose what identity is. Identity is so much, and it depends on who's looking. And so I started to think like, well, what actually, what is identity? How can you really like understand it? And then I started to think, well, at some point I had no identity, right? And then I did. And so I started to think, well, when I was born, my mother named me Stephen, right? And you could say that she attested to my name, right? And then I went to school, and the teachers, they attested to my grades, right? And the kids in the class, they could have attested to whether they liked me or not. And the government attested to my passport and my driver's license. The universities attest to your diploma, and an employer can attest to your employment, or if you're a good employee or not. And so I realized actually you can represent something as complex as identity as an aggregate of attestations. But the attestations, you have to be able to attest about anything, right? Maybe someone's Mickey Mouse Club subscription when they're a child somehow has some value to some person. Probably many people it doesn't. But it's important to be able to have this mechanism where anybody can attest about anything, and from those attestations any other entity can derive some sort of relative reputation. And so like this kind of also solves the issue where like you know it solves the one world government score problem, because rather than looking at attestations just from the government agencies and being like, oh well, this entity has a score of 400 no matter who's looking, right? But that doesn't make sense, right? You'll always trust your friends more. You'll trust the friends of your friends more. And so EAS allows you to aggregate these types of attestations and then for yourself derive what do they mean to you, based on how much you trust the people that are attesting. And so but it's useful for so much more, even though initially it was kind of designed, or it kind of came to it because I was trying to solve identity, and then realized like because it's just such a simple primitive that can be used like for any kind of attestation. It's super useful for anything, signing documents, um, you know showing that you trust someone or that you met someone. um, there's honestly infinite use cases, because I mean we say things all the time about things, we just don't have a digital way to kind of sign it. Like I say I trust this guy, I say that I rate a restaurant 5 stars or something, but the way I'm doing is I'm putting it in a siloed system. I go to Google Maps and I give it 5 stars, 4 stars. But with EAS, you can have an attestation that can be imported into Google Maps, but then used somewhere else, and that's kind of the beauty with that.
I think that's a great intro, especially it's pretty flexible in terms of like the sentence or like the statements which you can attest to. So I'm curious, like, so what exactly is EAS itself? Like, is it, yeah, can you like explain to me technically like
Yeah,
what it is, like
sure.
how it has like the off-chain component as well? Like, I'm quite curious.
Yeah, absolutely. So EAS has two components. It has an on-chain smart contracts, and then a protocol for making off-chain attestations. And so the way the smart contracts work is you have two main smart contracts, and it's very simple, by the way. Like the contracts are very easy to read, and this primitive does have to be simple, right? Because like the building block can't be too complex, because then you're limited to what you can build. And so there's something called the schema registry contract, and it allows anyone to register any type of schema. So, for example, if I want to say I met you in real life, maybe the schema just has like a single Boolean field that says met IRL, and that's it, right? But you can make a schema as complex as you want. So it can have like nested data and all sorts of stuff. And so you design a schema, and the schema defines like what is the type of attestation that you're making. So like Coinbase, for example, attests to users who they've KYC'd, and they'll attest this is a verified account, and even optionally, like this entity exists in this country. And so you have the schema registry, and they have a schema for that. And so anybody who wants to know whether or not someone has a verified account, they say like, does this address have any attestations of this schema type from Coinbase? And so they know that's a verification type attestation. And so the schema registry is really important in kind of creating like the category of attestation, right? And then once you have a schema registered, you can attest. You can attest using the EAS main contract, and you reference a schema. So you say, I want to attest Met IRL. You reference the schema, the bytes32 schema ID, and then you attest to the data, true or false, whatever the data is set up like. An attestation has a few different properties. So it has an attester address, right? This is the signer. It has an optional recipient. So, I might attest to Austin's address, or maybe I'm attesting to my own address, or maybe I'm just attesting with no recipient. Like if I'm tweeting, I'm not necessarily tweeting to someone specifically. Maybe I am, but maybe I'm just saying something to the world. It doesn't require a recipient. Attestations have a timestamp, which is super important. Attestations can be revocable. Attestations can expire, and attestations can reference other attestations, which is pretty cool. Another thing that's pretty interesting is in the schema registry, like it's very simple to create a schema. Is very and in general, everything is permissionless. However, we added this really cool feature to schemas. When you register a schema, you can give a schema an optional resolver smart contract address when you create it. And so when you do this, anytime an attestation gets made of that type, it runs through the logic in the resolver. And so the resolver can prevent certain entities from attesting. It can, it can create an NFT for when someone attests. It can send a payment. It can do, it allows you to basically extend the functionality of attestations to kind of whatever you want. And so, you can have schemas that are fully public, anybody can attest with them. You can have also schemas that are public, anyone can attest with, but there's some logic there. And then you can also have some permission schemas. Like, for example, Coinbase has a schema in which they are allowed to attest with it. So if you see an attestation from the schema, there's no way anyone else but Coinbase could have made. And so that's the general on-chain mechanism. And so for off-chain attestations, it follows the same thing. In order to make an off-chain attestation, in general, you would register the schema on-chain, but you can make the attestation off-chain. And so it uses EIP 712 to make an off-chain signature on the attestation data. And so we created an SDK, which makes it extremely easy to make these off-chain attestations and verify them. Also create QR codes from them. So we actually have a EAS Explorer application on all the chains that we support. It's called EAS Scan, and it allows you to like view and see. It's like the Ether scan of attestations. You can see all the attestations that come through. You can validate them. You can load off-chain attestations and verify them. You can make off-chain and on-chain attestations and schemas. It's a pretty cool tool. And so we provide these tools to make it extremely easy for anybody to be able to just start attesting right away. And also, what's cool about this Explorer is you don't even need to necessarily have any technical skill to be able to attest, right? So if I create a schema of some particular type, I can share it with somebody, and even if I didn't build like a specific UI for making this attestation, I can point someone to the EAS Scan website and have them make these types of attestations directly in the UI.
There's some kind of technical, interesting things here. Thinking about off-chain attestations versus on-chain attestations. Thinking about how an attestation has an expire. That makes a lot of sense. Like if it's an off-chain, you're going to want to have that expire on there. So, everything happens right when you sign it, and then you don't have any control of it after that. It kind of goes, right? And so that makes sense. But then you said that there was a revoke. And the only way to make revoke work is to have that thing on chain. And I think that's the data availability, I think. But maybe let me just like pitch that back your way. Don't you need that smart contract on chain with that data availability to make that revoke work?
So, we built something pretty cool for that. So, two of the functionalities that we added for off-chain attestations, and it's built into the EAS contract. One is a timestamp function. Allows you to so every attestation has its own unique identifier, which is a hash of the attestation. So by calling, like, we have a timestamp function on the EAS contract, you simply pass the UID, which is a bytes 32, and it stores a mapping of the bytes 32 to a timestamp. So you can actually know that actually this attestation happened at least before this time. And it's for revoking, similar. When you want to revoke an attestation, we have a revoke timestamp, except the way it works is it stores a mapping of revoker and timestamp. And so if you want to know if a particular off-chain attestation is revoked, you would check, did the attester call that revoke function and timestamp it on chain. And what's cool is also you can create a Merkle tree with like thousands of attestations that are being revoked or timestamped, and you can verify that all of them, have been for very cheaply. You can make this attestation for the cost of 1 bytes 32, mapping storage.
The very cheaply stuff leads me to the chain question, which is next. But before that, I want to ask the 712. I think you mentioned EIP 712. When we're doing all of this schema registry stuff, it just feels like the sign type data standard. How do those things work hand in hand? In terms, I think you said EIP 712 earlier. Is that the EIP you're referencing? Yeah. Okay. So how does EAS and 712 kind of work together? Because it seems like they're very similar things. You define a schema and then you attest to things within that schema.
So the type data in the off-chain attestation includes only like the main attestation field. So you have the attester, recipient, timestamp, but the data is just typed as 1 bytes field. And so we did build like a MetaMask snap and other tools to be able to like decode these off-chain attestations in the extension when you're sending a transaction. But the schema doesn't change for the off-chain attestation. 712 schema does not change for every single attestation, and it would actually create issues and make it a little bit harder for other developers to kind of verify this stuff on chain, because they'd have to write a completely different kind of verification logic. Yeah, and the data is just ABI encoded with the schema.
So it's similar but different, not exactly the same standard. There were things that you needed, and I think really like the thing to hammer home here is how generic you made everything and how open source and easily accessible you made everything. You didn't want to add any kind of the subjectivity comes on the next level, the relative subjectivity and all that stuff. What you want is a nice dry layer that does exactly what it needs to do, and everyone can get to it, and it's super generic. And everyone can get to it leads to my next question. Sorry, you're about to say something, and that's the chain thing. What chains are you guys on? Of course, mainnet, but what else?
Yeah, so I mean, we're pretty much on every chain that's currently being used. Let me just quickly
that's subjective.
Just take a look. Like, not being used, sorry, but it has like developer activity. We're on mainnet, obviously, Optimism, Base, Arbitrum, Arbitrum Nova, Polygon, Scroll, Linea, ZK Sync, Celo, and then a bunch of testnets as well.
Good list of L2s.
Thank you. And we're always growing it, and sometimes people even deploy the contracts themselves to other chains that we don't support yet. And then, if a lot of developers go there,
that's amazing.
Put the Explorer on it, and we'll like run our resources. And, an important thing that you mentioned before is that that it had to be open source, or that we did it open source. It has to be, right? Like I kind of look at this example, like imagine if email was closed source, right? And then like everybody had to pay for it. And then you'd have like Fmail and Kmail and all these different, versions. And you'd be like, oh, which version of mail are you using? And that doesn't make sense. We wanted to really solve this problem. And we're thinking like, no one's going to, so if we charge for it or we try to extract value at this layer, someone else is going to make a different version of it. And like, we definitely don't want that. That just creates more fragmentation.
Okay. So like as a developer, it's like completely permissionless. I can go ahead and I can integrate into my dApp. No fee to pay, so it's free service as well. And so I know that you're a public good. So basically, yeah, not really extracting value from the users, but just kind of providing it to the whole community to use. I'm curious, like, can you talk about, like, we talked about the use cases, but like, how do you see EAS being used now, like by developers? Like, are there any use cases which you think are cool and being built right now? Yeah, just kind of how are developers using EAS today?
Yeah, so a lot of the use cases, I mean, many of the use cases have been around like gating certain things. Like, so for example, you have Gitcoin Passport, right? Gitcoin Passport, they maintain all their scores off chain as like verifiable credentials. However, they have a tool if you want to be able to prove to some smart contract that you have some particular score, you can pay Gitcoin Passport and they will make an attestation on EAS with your scores. So you're now able to like bring your your Gitcoin score or Gitcoin Passport score to for example use it in like a gated airdrop, and so that like prevent Sybils from attacking it. Same thing with like Coinbase. Coinbase has like a massive program called Coinbase Verifications. They've made like almost 700,000 different attestations for different Coinbase users, and they have a bunch of tools like base paint, and they offer, like for example, if you have a Coinbase one of these Coinbase attestations, you get like uh, uh, you can use the faucets like much more often, and you get a lot more from the faucet. Also, there's Coinbase One attestation. I believe if you have the Coinbase One attestation, you get like some of your gas fees subsidized. We have like platforms like receipts XYZ, which allow you to like bring all of your like Web 2 data to Web 3. So like they will, they have like an OAuth setup where like you connect to your, like for example, to your Strava account, and then you have attestations being made about like how many miles you've run, or how far you've swam and stuff like that. um, Optimism attests to RPGF badge holders using EAS. ETH Global was attesting to like people who were like meeting each other at like the recent event in Brussels. Um, it's actually like kind of crazy. There's so many different platforms that are using it for so many different things. Um, a lot of it has to do with gating, and I mean over time, as more and more people attest and entities attest, you start to have this kind of like rich like data that can be used for so many different things. And it ends up being kind of like a chicken or egg problem, because you can't really build a lot of the platforms until the attestations exist, but now they're starting to, and so we're seeing like lots of growth. Like I think 3 months ago or 2 months ago, we were at like 1 million attestations, and now we're like 4.5 million attestations. Like, and this is, we've only been live since 2023 in March. We launched at ETH Denver.
So you mentioned like attestations for how good of a dancer you are. Let's pretend like we're a developer and we're building a dancing platform, and we want to attest to your dancing skills. As a developer, we would go set up a schema. We would say, this is we're gonna have a name, we're gonna have a dancing style, and then we're gonna have a score, and that'll be our schema. And I probably could do that for even from Etherscan. That schema is probably super easy to set up. And then as a developer, now I want to start sending attestations into your system. I would have to write some code to have them basically. I would have to write some code to prompt them to sign that information, probably something. So I would fill in the schema, and then I'd have them sign something, and then I'd send it to your contract. But can we get in a little bit more of like, I'm a developer, I'm building a dance app, and I want to start sending these attestations on chain? Do you have an SDK? Do I talk to your contract directly?
So I mean, there's multiple ways to do it, right? So we have a schema creator right in the Explorer, so you can like literally set up the fields and data types right there, deploy the schema, and then you can click on the schema and then just start a testing right in the UI to the schema that you just created. So you can do it that way, or a developer can build like a nice React app with appropriate fields for the specific, like maybe like pre-filled boxes for the different dance styles with icons for showing you the different dances, and the attestation would just automatically happen, and the user just gets this really nice interface, and then they can point the user to the attestation on EAS when someone wants to verify, oh, this actually is an attestation on EAS. But in general, like developers will probably be building on top of it, building UIs on top of it. It's kind of like you can use the Explorer to attest, but it's kind of akin to like using Uniswap with Etherscan, but like a little bit not as bad, but depending on how complex the schema is.
So no SDK, is that right? Oh yes, there is an SDK.
There is an SDK,
Okay.
right? There's a TypeScript SDK.
Okay.
And
That's probably what I would use if I was building it. I'd probably go grab your SDK and kind of look through your docs, and I'd probably make the schema raw with the editor because I only need to do that once. But then
right.
having them fill in and sign the SDK, or having them fill in and sign that type data, I think I'd go start messing with your SDK and see if I could bring it in my React app or something.
Exactly. That's how you would do it.
Cool. Okay, so that brings up the next question, and let me see if I can bring it on stage. Is that true? You guys made an EAS is true app by forking Scaffold-eth, this is really cool. I love to see forks of Scaffold-eth in the wild. But could you tell us a little bit about is that true? And is Vitalik actually 7 feet tall or not?
So we were thinking about, when we were coming to Brussels, we wanted to just build an example application for developers, because we were at ETH Global, and we were just helping developers use EAS, and we wanted to give like a demo application that was newer. We previously made one called Met IRL, which is like a cool application that allows anybody to just like attest to someone that they met in real life, and then the other entity to respond and say, yes, I did meet this person. But I wanted to create another simple application that had some server side stuff going on, and so I was like, all right, like I can build a next JS app from scratch, or like I can use something that's already there, that already has everything all plugged in, and so I use Scaffold-eth and put this together, quite quickly, actually, probably like an hour or two.
That's awesome.
And so the idea with this application is you write some sort of statement, true or false, and the statement gets sent to the server. The server sends it to OpenAI. You can actually, if you click on any of these, so there's a view attestation details on any of these, and you can see this is the off-chain attestation. It just decoded in your browser, and you can see there. This is the schema to testing to the model. The validity can be a few things. It can be like valid, like it can be like invalid. It can be like vulgar, like unsure, and yeah. So this makes it super easy that you can just share this off. And we did it with off-chain attestations because we wanted to just make it free first off, and just make it. Someone might ask a question that they don't necessarily want on-chain. But imagine you're writing an article and you make some sort of statement, and you want to be able to you want to kind of be able to cite it, but without having to cite it from some other website somewhere else. I can say Vitalik is under 7 feet tall, and then I can take this attestation, off-chain attestation, as a URL and just post it as a citation, and then someone else can see, oh well, the address that signed this was actually this company that is trusted and runs this LLM and does this. Additionally, you can also attest, upvote and downvote the attestations, and what that does is
here. Yeah.
Yes. So if you upvote the attestation or downvote it, what happens is you actually make an attestation referencing the initial attestation ID, with a completely different schema, just a schema that's is true. So so I'm not sure if any of these actually have scroll down. Oh yeah, there is one. So there's a reference.
That's me right there.
Oh yeah, nice. Yep.
I've met him in person. He's not 7 feet tall. He's tall, but he's not 7 feet tall.
Oh, This is under 7 feet. Under seven.
He is under 7 feet. Yes, I can attest to that.
Nice.
Awesome. Okay, and I would love to get this. You should just link to this so we can throw this in the notes. If someone wants to fork this specifically, it'd be cool if they could take this and fork it also, just to see how you built the app on top of things.
Absolutely, yeah. We have it on public on GitHub, so
Great.
you'll be able to find it.
I'll steal that link from you and we'll throw it in the notes.
Sounds good.
Yeah, we'll add it to the description below. I also want to talk about so I know you recently launched Transitive Trust, which is, from my understanding, like an algorithm for reputation system based on your closeness. But I'd love to hear like your explanation on like what Transitive Trust is, like how it fits in together with EAS.
All right, so it's super important. Like, if you want to be able to solve decentralized identity, you have to be able to understand, like, you have to be able to have something called relative trust. You have to be able to derive how much do I trust this entity based on how much I trust other entities, right? Rather than just trusting a single entity to tell you how much you should trust everybody, which doesn't make any sense. Or something that's a little bit more natural, right? Like, for example, if I'm looking for a plumber, you know, I can go on Google and find like what people are rating as a plumber, but I don't know if those reviews are real. I don't know if those guys even know what a good plumber is, right? But if I ask my friend and they give me a recommendation for a plumber, that has like a lot more, there's a lot more trust there. And even if my friend's friend recommends somebody, there's some value there too, right? But as you go like a few hops away, it becomes really hard to make sense of any of this, right? So we built so before we built this, we were looking at all these different algorithms that existed, that people have been using to calculate scores for different types of edges, which could be attestations or any kind of signals. And we messed around a lot with PageRank, with eigentrust, which has nothing to do with eigenlayer. It's just it's one of actually the biggest ones. Like, there's something called OpenRank. I believe it uses eigentrust as well. The thing about eigentrust is this was an algorithm that was built in 2003 specifically for deriving reputation of seeders and leechers in a BitTorrent like file sharing network, right? And so it wasn't really built for something like deriving like how much you should trust somebody. And because when you're deriving the scores for the file sharing networks, there's multiple points of verification. So like, you're not just relying on what the one entity is saying that this person's uploading or downloading. You're getting it from like a bunch of entities, so it works in that type of system. And also, it's not super mission critical if like one person gets like a higher reputation even though they've just been like leeching from everybody. Like, okay, you're gonna like you lose a little bit of bandwidth, but you're not gonna lose your house. And so these algorithms, these algorithms have like these properties that make them not super useful for deriving reputation, because there are cases where, say, for example, I want to say that I trust you, but if I do that, somehow I will lose some of my score, and that just makes no sense. Like you need to be able to have a scoring mechanism that doesn't necessarily change when things like this happen. And so we built this new algorithm from scratch, and it deals with specifically, given that I trust you and you trust someone else, and that person trusts someone else, and then I have other people that have trusted some other person that trusts somebody else that maybe also trusted that person, and then maybe I have another person that distrusts that person. How do you derive like how much should I trust this other person in the network from my perspective, not just from the global perspective? And so this algorithm is really fast. It's much faster than eigen trust for things like this, and it actually works. Jacob Kermeyer, who worked for us, he's also actually my cousin. He actually wrote this algorithm, and we released a paper a few weeks ago. Yeah, I mean, like we want to have more and more people kind of look at the paper and test it out. And it's really amazing though, because I've been, since 2020 actually, I've been playing around with these types of algorithms for deriving relative reputation, and have never found a single one that gave you scores that made sense. And this one actually does. So it's definitely something that cool to play around with. And it's not necessarily related to just attestations. You can use any signals. Maybe it's like, transactions that you're using as edges, but it's completely open source. And we think it's state of the art for deriving relative reputation.
So your cousin's the math nerd, the graph scientist.
He is a massive math nerd.
And all of this stuff that you're talking about is kind of a layer up. Once you have EAS and you have the dry system that works and does exactly what it needs to do and lets anybody attest to anything, that's like step one. Then it's like, all right, now we need all of this relative trust stuff and this graph theory stuff, trying to almost like get yourself some product market fit with the thing that is already kind of doing what it needs to be doing.
One thing, just to be like transparent, we actually don't plan to we're not planning to build or use, like, EAS will not derive scores for people, right? That's not the point. We're just releasing these tools so that other entities can derive reputation in their own way. We're just giving people the building blocks so that we can actually really solve, decentralized reputation for real, right? Like when Ethereum came out, everybody was like so sure that we're going to solve, real estate and voting and all these things on the blockchain. But like, if you have no solid reputation, you can't solve this problem. And like, before EAS, imagine I wanted to say, like, I wanted to find some sort of way to say I trust you or I met you. Like, do I hire a developer to build a smart contract that like just allows me to make this kind of intention? Like, it doesn't make sense. And that's why it required this primitive. And also why I think, and I didn't mention this, so Optimism implemented EAS into the OP stack. So every chain that deploys with the OP stack automatically has EAS built into it, because they thought that it was such an important tool that it should just be built into the chain. And so like on OP stack chains, the address for EAS is like 0x42, all zeros, and like 20 and 21. Which is pretty cool. It makes it easy to use and know that you're working with like a legitimate contract.
Like you said, when people are deploying their own chains, they're kind of deploying some of your contracts. It's just a set of smart contracts and a protocol. Like, it's just software that runs on top of it, and anybody can fork it and use it. That's pretty cool. I was thinking reputation. We need a reputation system for like stakers, solo stakers for a Slido, and somehow be able to attest to that or something. But that would take a whole system of weird math, figuring out pings. I don't even know what it would take. So Edda brought something up really interesting earlier that I want to ask, and that is privacy. Like, all of this stuff is kind of like public and out there, and maybe it's just a byte string and it's not. I mean, I think you just decrypt the bytes and they show up, right? So does ZK Tech come in here? How are you guys thinking about privacy and attestations and zero knowledge? Is that it's kind of coming into like mainstream, like users can actually use ZK Tech now?
So we've built some tools for that, right? So for on-chain attestations, right, the data is public, but you like the way you encode the data. Like, for example, we built a tool called for private data and selective being able to selectively reveal private data. So imagine some like doctor's office attests to all of your medical records, right? And then you want to prove to another doctor, like, that you received or to the insurance company that you received some specific treatment, right? How do I prove that without revealing all of the data? And so we built a really cool tool. We implemented into the SDK and the EAS Scan Explorer. And the way it works is you can basically attest to infinite amount of data. We Merkleize it into a Merkle root, right? And the only thing that goes on chain is just the Merkle root, right? And all of the leaves are salted too, so you can't like brute force them. And you're able to, if you want to reveal some particular piece of that data, like for example, one particular treatment, you can just show that leaf. All you do is you basically just show that leaf to the person who needs to know, and you give them all the side hashes, right? And you don't have to manually do this. It just, the SDK handles this and then allows you to verify that, oh, actually, this was attested to by this. You can see that this attestation came from this entity to this entity, and so that's one mechanism, right? Off-chain attestations are private by default. So like when you make an off-chain attestation, like EAS has no idea about it. Even when you do it on the Explorer, like we have no idea. We have no way of knowing. Even when you're sharing them with other people, we have no way of knowing because everything happens in like the browser. And so like you can have attestations that are just shared on a need to know basis. And then also what we're working on right now is the ability to make zero knowledge proofs off of off-chain attestations. And this has been really fun. So imagine you have the government that attests to your birth date, or maybe like your birthday timestamp. And then now I can make a proof, maybe they attest to a bunch of other stuff too. And I'm able to make a zero knowledge proof that I'm actually over 18, right? Without having to reveal any of the other data, except that the attester was like the government or some entity that someone cares about. So this is something that we're actively working on, and we've been making a lot of like good progress. And so we're like we've actually been using the RISC-0 implementation. They open sourced their proving code and verification code, so we've been getting some pretty good progress with that, and hopefully in the next couple weeks or so we can release something that everybody can use.
You were talking about the government attest to your birthday or something, and that reminds me of well, it reminds me of the NFT craze and how we were talking about NFTs being passports, and instead they became $1,000 frogs that are now $1 frogs. but it reminds me, the government does attest to so many things. Like you have an RSA signature in your passport from a government signer. And like all of this stuff is coming together, and like eventually this will be all mainstream, and all of this stuff will just be like a utility kind of underneath the abstraction to people. But this is a base utility for attestations that I think the future in the future all humans will use. They just don't know. They just won't be knowing it, right? They'll carry their passport around, and yes, it's an NFT, but they don't know it's an NFT. And yes, it's on chain, but they don't know what that means. They just know they walk up and hit a thing, and it lets them into the place, right? So backing all the way. Okay, no, go ahead. Were you gonna say something there? Let me back up.
I was just gonna say EAS will be successful when no one knows that they're using it.
It's a blockchain. Yeah.
Yep.
Okay, so it seems like an obvious home run application. Someone should build Web3 DocuSign. The little DocuSign links you get in the email, you click a thing, you go in, you sign in, it's all attested to. EAS has everything there. Who's built it? Is it out there yet? There's been some attempts, but I haven't seen DocuSign just get replaced by an EAS competitor.
So I mean, we built like a schema called signed document, right? And we even built a UI into the Explorer where you can just drag and drop any file. It automatically hashes in the browser. You can write a little note and then make the attestation, and then anybody else can see that attestation, drag a file into there, and see whether or not the hashes match. So we've done stuff like that, but we haven't seen like during hackathons we've seen like example applications like this, but nothing full featured.
You need
like
the CEO. You need the product person to say, okay, I can make this, and I can go to humans where they are now, right? We're not asking them to come to blockchain. We're going to go to them where they are, and we're going to create this DocuSign system that uses all this tech, but it just works for them in email and dynamic or something, privy or something like that. Yeah.
It's such an important tool, because today, like if you DocuSign, like they can sign any of your documents if they want, right? Like you're just trusting DocuSign as this like as a note, as like a notary that that they're witnessing the signature, but like you're not actually you're logged in with like a password. Like anyone can steal your password and start signing documents on your behalf. Like how much better would it be if you can use your hardware wallet to make a signature on a document? And that's what you can do today with EAS. There might not be yet a beautiful front end application for this, but it's actually quite simple to build.
I think there are like really good next steps for developers, like especially like to build the apps we just talked about, like DocuSign. But also you mentioned like to look into transitive trust and like build around there. The first thing there comes to mind is more around like building something for Craigslist. Like when you buy something, it can be like you can have more trusted reputation than like randomly buying like a motorcycle or something. But Steve, this was great. I think there's a lot of nice next steps. Maybe some last notes, especially curious where people can find you. I think you guys are at like hackathons. Just, yeah, thank you so much for coming on here today too.
Thank you. It's been great to be on. The main website for EAS is attest.org, and you can find like all of the developer resources and documentation for how EAS works, examples of things that you might want to build, example use cases, and basically everything you need to get started. I would start there, attest.org.